So today is all about tables. This is going to be the lecture, by the way. This is why I'm so excited. This is going to be the lecture where like you feel like you can actually do data science, because like we're going to know enough by the end of today to like do something meaningful and like take a data set, which is just like a CSV file, take some table that we're reading into Jupyter and like ask questions about it that we might actually care about asking. All right. And we'll know how to answer them too. So that's our goal for today. Okay. And this will be chapter 6 stuff. So please read chapter 6 if you can. But I'm going to try my very, very best to take 2 lectures for this. But it's going to require your participation. We're going to go slow. All right. So there's going to be just a very long demo at the start. And I'm going to teach you all the things about this chapter. And then I'm going to ask you to do it too. Okay. So if you could please get somewhere where you can work, I'm going to need your help. So if you're on like a big computer, if you don't have something installed, you can always scroll down to here, click the magical link, and I'll show you where to get all the data stuff for today as well, the CSV files. Okay, so I would like to start a new file in my Jupyter Lab program. Boop. New file. Am I in the right folder? Yes. And I will call this chapter 6. All right. And okay. We actually know a little bit about tables, right? The table type from the data science library. If we ever wonder about it, question first.
Super question. Are we doing attendance? Was that open that I missed it?
Oh, yes. Yes, I already said attendance. Attendance is going. You can still do it. No worries. I'll keep it running for a little bit.
Secondly, were you recording or are you recording?
You missed me click a lot of buttons.
Yes.
We are recording, but I appreciate that you asked, though. Because if I forget, you got to yell at me. So keep on asking. Thank you. All right. So yeah, we should be good, I think. Yeah. Let's talk about tables. And if you ever want to wonder about anything in this class, these are like the 2 links that I care about you clicking. They are, I guess I gave you one here. Let me give you the other one here too. Python reference 1 and Python reference 2. 1. And then the other one is... Honestly, I might like this one a little bit better now that I'm looking at it. So I'll update the Canvas page real quick. Let's call that one Python reference 1 if I like it better. Boop. I think this is how you can add a link on Canvas easily. Yeah. 1, 2. Cool. So now if you refresh the Jupyter Lab page at the very bottom, if you want to click this, that works. You can also go to these 2 links, and I think I like the first one. I think I like this one because it says what you can do. It's everything that's in that data science library, everything that they've given us access to. Okay, so if you scroll down, you'll see like table stuff. Table.read table. We've used that a lot with a file name to like get the contents of like the ice cream file or something. We've done stuff. And then if you keep scrolling, or also look on the left, it'll tell you all the things you can do to tables. Like remember, we did select. Remember that one? We did drop. I think I showed you show. We did sort. Like it's all there, and you can click on them, and it's all on this page. So like you can scroll down and it like has some examples, descending, all the things you could want to do, and we're gonna learn a lot more. So I think this is a good page to look at and like look things up with. There's also this page, which is a little bit more compact. I don't know. It is missing some of the things here, I think, though. So like maybe use them together if you can. If you're like in a bind, you want to do something really quickly, I think this is useful still. But together, they give us the ultimate power. So I'm just going to go through a lot of things today. So yeah. Let's start with tables. So I would like to import the data science library. I want access to that table thing to make tables and work with them. And so I'm going to say from data science, import star, everything, the world, the universe. And let's see if this works today. Cool, it finished. And so if you're on this little temporary page for you, that's here. You can just run this entire thing. I might also do NumPy as well. This stuff down here is for graphing. We'll get to that next chapter, but you can keep it there if you'd like. But all right, we did it all together. All right, and now I guess you don't have to type every little thing I do right now if you don't want to, but eventually I'll ask you to do stuff. So let's start with just tables. Tables in general. You can make a table by reading from a file, like it gives everything into it, like we were talking about, I don't know, ice cream. You could read that table in if you'd like with table.readTable, or you could make a table from scratch. So you can say table with parentheses, like a function. It's essentially a function. And what that will do, if I do Shift Enter, it gives me blankness. And what that means is I have an empty table right now. I hope that makes sense. It's like it makes an empty table. There's nothing in it yet. And so obviously it's not going to show me anything. Empty table. Okay, empty table. Cool. I can start from an empty table and put stuff in it slowly but surely. There's table dot with underscore column. You'll get used to all of these, I promise. And with underscore column takes two things. It takes the name of the column you'd like to add. Remember that a column is something that goes this way. It's like, I don't know. You got labels for your rows, label 1, label 2, label 3. And then those, and then you got a bunch of like data, A, B, C, D, E, F, G, H, I. This is a row, and this is a column. All right, so every column, you can add a column one at a time, just give as many things as you need. So you can say table.withColumn, and you can give it a name and give it some contents, and the contents of it have to be a sequence. How many things are in that column all at once? So we can make a sequence with arrays, remember that, right? And that's from last time. So again, I want you to get comfortable looking at this kind of thing. So like you scroll down, table.readTable gets it from a file. If we start from an empty table, you can add a column. It's like with column name values. And so here's like how you would read this example. It's like you have an existing table, you can add a new column to it potentially. And here's the name of the column. And here is the contents of the column, apparently being calculated from other columns. But we can add them all from the start. All right. There's also dot with columns if you want to give a bunch at once. Just like give a name, give a bunch of, give that column, give another name, give that column. I'll show you all of those. All right. But this is how you kind of read this page. And I want you to get good at it. All right, and just stop me at any point. All right, this is just a demo right now. So okay, let's make a table of people. All right, and so the first column will be their name. All right, so I'm going to start with an empty table. All right, so that's table parenthesis parenthesis. That gives me the empty table, and I can attach onto it new things. So with column, the name of the column is going to be name, and the contents of that column is going to be an array. So I'm going to say make underscore array to create that array and put stuff in it. All right, and so I'll put me in the table. I'll put my cat Lonzo in the table, and we'll put the other computer science professor Bill. He'll be in the table as well. Feel free to put yourself in the table if you would like to play along. But what I do, what happens when I press Shift Enter, is it created that table, and now I see it in a pretty way. It kind of went away though because I didn't save it anywhere. Just like it vanished. If I wanted to have this table for later, I could have called it something. It'd be like, all of this stuff, bless you, equals like T. That's my table. It's called T now. But I just created it on the fly just to look at it, essentially. All right, so that's my table. I've added a name column, and here is the contents of the name column. Does that setup make sense to us? Stop me at any point. All right, so that's some data. Cool. Now, what if I wanted more data? Well, I wanted more information. I could start with this if I wanted to. Or let's do it all over here. Let's do with columns this time, plural. All right, so table.with columns. So empty table, starting from an empty table, attach onto it, because the dot just kind of means, hey, the thing before me, I'm asking you to do something. All right, so hey table, hey empty table, take yourself and add some new columns. All right, so I'm gonna try to make this look a little pretty. So like I can press enter and it kind of tabs over for me, which is kind of cool. And so I can kind of do two of these. Like, all right, there's the first column, name column with a bunch of names. And then I need to give, well, let's do like an age column with, and I can like, I need a comma right here. These are technically a bunch of arguments. I need a comma right there, age column. I can space over to make it all pretty. And then what I want to do is like give the age of all these people. All right, make underscore array. And then I'm going to give an array of numbers. I hope that makes sense. I'm 32. My cat is 5. And then I don't know how old Bill is. I'm going to assume he's at least 1 year older than me. All right, so that's like the age column. Does that make sense? It's got to line up though. And now if I hit Shift Enter, we have some data. Now we have rows with information, right? My cat, he was born in June. He just almost turned 5. And so, yeah, now you have a row with a name and an age for each individual in that row. So columns, rows. So there's 2 columns and 3 rows in this table. And the labels of this table are name and age. Does that make enough sense? That's data. We have some now. I'm pretty sure it will yell at you if you try to give more or less of one. Like, I don't know. Now it's very unhappy, right? Because I gave 3 things for this one. I gave 4 things for this one. You can't have... Now one row is missing something, yeah? So that's not good. So it will yell at you, and it's like column length mismatch. That's good, I guess. It's telling you that that's not going to work out. A little scary of a message, though. Okay, so there's my table, and I can store it somewhere. Right? Again, it's like it's vanishing the second I use it because I haven't saved it anywhere. So if I want this somewhere, I can say equals. Save it into a variable name. So I'll call it like people. The table will be called people. And if I hit enter now, it doesn't show me anything because every assignment statement doesn't give me anything back, but it's saved now. So I ask for people. I can always get that table back. All right, that's saved into a variable, safe and sound. All right, so that's quite nice. And once you have a table, again, we started from the empty table and added stuff, you can start from an existing table with actual rows and columns and put new things in. You can say, okay, people table, I'd like to create, I'd like to attach onto the people table some new columns. You can do the same game. You're like people.with_columns, new stuff. So let's give like an employer column. I don't know. And then who is the employer of all these people? So it's going to go in the order of me, my cat, and Bill. So make array. I guess this is going to be an array of strs, right? An array of words, so stuff between quotes. Could be double quotes, could be single quotes, does not matter for Python. So my employer is this college. My cat is unemployed. And then Bill also works for Clovis. All right. So that's us attaching things, and honestly, it doesn't really matter if you use with columns and only add 1. It's still fine, even though maybe you should have used with column. It doesn't. It's still happy. All right, and give as many as you want. And that's made a new little column there attached to the people. All right, attached to the old people table. So it's fine to use the plural with columns and only add a single column. The flip side is not true. You cannot say with column here and expect this to work. It's like, I only can take 2 things if you say with column, but with columns is like, it's happy, okay? So yeah, this is my bigger table, and every time you say with columns, with underscore columns or with underscore column, it creates a brand new table. It adds on to that table that you gave before, like the empty one or the people table. It takes all of those things and it adds on and gives you back a new table and does not change the old one. All right, so if I look at the people table again, notice that it does not have the employer column. So that's important. We want to be able to build tables off on top of existing tables and not mess with the old ones so that we still have those if we need them. So people didn't change. So that's beautiful. We know that now. What else could we ever want to do? Maybe you read in a disgusting CSV file and you don't like the names of the existing labels. Like, for example, Pokemon. I am not the happiest with the way that they named these labels. It's like abilities against underscore bug. I guess that one's fine. But like type 1, in my opinion, should just be called type. I don't know. Something like that. Maybe you don't like the name of one of these existing labels and you want to change it. So there's an operation for that. So again, it's on this page, it's on this page too. Let me show you how to find it. Just like read through, like what can I do to a table? It is .relabel. Which kind of makes sense. You got a table, you say, hey, that table, it's always dot is acting on the table that came before it. Table.relabel yourself to have that old label of the column change to a new label. All right? So if you have, let's say this is our cookies table, and they can relabel quantity to amount remaining, and now it looks like this. So it has a new name, which is maybe shorter or more accurate, whatever you needed at the time. All right, so you can do that programmatically with a .relabel. So I can say people dot relabeled, or dot relabel, I guess is fine. There's also a dot relabeled. And let's see. Do I want to teach you this one or do I want to teach the other one? It's a great question. Oh man, it's not there. Is it here? So yeah, here now they're disagreeing. There's one called relabel that other page has that's going to mess with the table, and then there's this one called relabeled that makes a new table. So I think I'd prefer to teach you this one. So that's why we have both of these open. Maybe I should make one of these pages with all the things I want to teach you, because that's a little silly. But there's a bunch of things that are not listed, and so this is, I guess, one of them. So relabel is going to mess with the table, but we kind of like the things that don't mess with the table. So I'm going to say relabeled like that, all right? So just remember that one might affect things. So let's say that, I don't know, I don't like the name age. I don't like that label. Let's change it to like trips around the sun. Something more flowery. And so remember that the old table did not have the employer column, and so relabeled, now I have that name. All right, so maybe that's a more accurate name, it's better. And again, relabeled at least did not mess with the original table. All right, still got just that stuff. If I want this one and I want to use this one for later, I can save it into something like people 2. I could save it, actually I can overwrite the existing people table if I really like this new one. Those are your options. You can overwrite an existing table, like people equals people mess with, because you're getting back the new one. You can immediately set it back into the old one if you want to do that. So you have many options, and I hope that makes enough sense. All right. Questions about that? Are we ready to read a file into a table again? All right. So let's do a dividing line, because now we're going to use a file. So if you do 3 dashes in Markdown mode, Shift Enter, that draws just a straight line, which I think is kind of pretty. It's useful for us right now. I would like to read into a table this cute little cones.csv file. So if you'd like to follow along, where you can find that file is our code from class page on Canvas. There's that data folder. So you click our class, you click the data folder, and then you click cones.csv, and then you can download it with this little download button. So you click download, and then you can drag it, like if you're using this, you can take it and be like, drag. So I'll show you how to open it there too. Oh, every time I reload that page, it's unhappy. But like if I go to my downloads folder, oops. Wherever you are right now, let me show you how this works. So you've downloaded that file potentially. So here's my cones.csv file. You can take it, and you should just be able to, no matter what kind of Jupyter Lab you're in. So go to the files bit, just like drag that thing in there. All right, and so that is, now you have it. Now you can access it. Okay, and so the way to, let me do it here first before the connection drops. The way to read a table read a file into a table is you say table dot read underscore table, and that's on both of those pages. Like, how do I get a table into a file? Table dot read underscore table. Give the name of the file as text, as a str. All right. So it now depends on where you put this file. If it's in the same folder as we're working in the Scratchwork file right now. If it's in the same folder, you just say, with quotes of course, cones.csv, and there it is, it read it. If it's in the same folder like that, and you can assign it to a table, like, I don't know, cones equals that, I'll have it print out after it's read it in. So now you have it in that variable. If it's in a different folder, like it will be if I go somewhere else, if I go back to my original program, for me, I've got this chapter 6 file, and I've got this data folder, and the data folder is what holds the cones.csv file. Okay, so if it's in a different place, I have to say that. It's always relative to where this file is that I'm working on. So cones, I want to make that a table from reading a table, table.read table. And it's not just cones.csv. I have to say what folder it's in. How to actually get there. Because that's the final name, but it's in the data folder for me. So I say data /cones.csv. So it all depends on where you put this thing. And so I'll read it into a variable, and then I'll just like put it on a line by itself to like have it printed out in a pretty way. Okay. So this is the ice cream cones that we have available to us to buy from the ice cream store today. Okay? So that's a table that we read from a file. It's got some baked in labels for the columns, flavor, color, and price with capital letters. And then it's got a bunch of rows. It's got 1, 2, 3, 4, 5, 6, 7 rows, 3 columns. All right? All those words making sense? All right. So you can always ask your table that you just read, like, you don't have to count the columns by hand. You can ask it. How many columns do you have, table? How many rows do you have? Here they all are. There's a dot num rows. It's a variable within the table. It's not a function. Dot num rows, dot num columns. They really like their underscores to separate words in Python. So here, cones dot, you tell me, num columns. We know there's 3, but it knows that too, okay? If you had a really long file, you didn't know how many rows there were in it. Num rows, that will also tell you. All right, remember that I'm pressing Shift-Enter to have this run quickly. You can also press the little plus or play symbol. So there's seven rows, so there's 7 like ice cream cone types, I guess. And then finally, there's also, you can get the names of your column labels in order if you'd like, with dot labels on the table's name. So that is cones.labels. You can always do that. And this is kind of like a sequence. If you think about it, you can go into that sequence and get a piece of it. And maybe I'll show you how to do that one day. But it's kind of like an array. It just gave you back a sequence of things, a sequence of labels, so you can see them. Okay? So that's all of that. What else do I want to say right now? Are we ready for the next slide? Not quite. We will get there eventually. I guess this one is a good one to get to. Let's talk about the fact that when you read, let's see, yeah. You can ask your table for just give me one column, please. Give me that column called flavor. Give me that column called price. You can do that if you would like, and you're going to get it back as an array, which is nice. All right, so where is that? You can say dot column. So I'm kind of going in order almost. You can say table.column, and you can give the name of a column or the index of a column. All right, so you can ask for, hey, give me the column called cookie. Give me all of that, and it's going to give you back all the data in that as an array. Or you can say the index of the column. So I guess I do want to go to this picture now. So remember that in Python, at least, in most programming languages, indices start at the number 0. Okay, they start at 0, and so if I want the first column, it's going to index number 0. If I want the second column, it's really index number 1. Okay, that's something to worry about. And so I can ask for, hey, cones.column, I don't know, I only care about the prices of these ice cream cones. So I can say column price. As long as you give the right name. Look at how I get back all the data in that column as an array. That's nice. And I can do stuff to that now, like multiply it by 2 or something, whatever needed to be done. So I get that column as an array, I can do array stuff with it. And because it also took an index, what is the index of this price column in this particular table? Can someone tell me? Knowing that indices work like this and they start at 0, what's the index of the price column? Good, yeah, it's 2. It's going to go 0, 1, 2. Nice. So I could have also asked for the price column by saying cones.column 2. And that's just a normal number without any quotes. It's an int. And so I get the same thing back. So it's slightly faster to type the 2, but it's slightly more descriptive to type the name of the column. It's up to you as the programmer. Okay? And yeah, so that's us using indices. Once you have, like this whole thing results in an array, right? And we can go into an array and get pieces, all right? We can go into an array and get pieces. There's a dot item on arrays to say, I want the 0 thing. So remember that all this is giving me this array. Let's say I want the 350 or something. That's index 0, 1, 2, 3. So I can say item 3 here. Do you see how it's being broken down like that? It's going to go in order. It's like start with the table called cones, pick out the column called price. Now I have that array. I've got this thing. And then pick out the index 3 thing, so really the 4th thing in that array. Do you see it? So that's kind of interesting. Okay, remember that the first thing is at index 0. So let me show that to you. This is really the 4th thing. So the first thing, if I want to get out the 355, that's index 0, not index 1. First 1 is at index 0. So does it kind of make sense how I'm chaining those things? That's important. Yell at me if you have any questions about that. But yeah, you can have fun like that all day long. And I think that's where I want to ask you our first question. So you can get out this price column, right? You can get out this price column like this, and you can mess with it with number stuff. Like take everything in that column and multiply it by 2. Like that's a possibility. So with that in mind, here's my question for you guys. I'd like you to try it. Please get that cones.csv file, read it in to a table, and try to do the following. This is our crushed ice for the day. For right now, at least. Crushed ice. Please calculate. What did we say that Fresno's sales tax percentage is? I think it's 8 something. 8 point, yeah, let's do 8.75 then. Ish. I need to bring a receipt in one day. 8.75% sales tax in the price column. Because sadly, prepared foods, they're not tax-free like when you go to the grocery store. So let's say we want to know, we've got our cones table, we got the price column. I'd really, really like to know the price of those ice cream cones after tax. Like how much money do I really need to bring to the store right now? All right, so you can get the price column like this, and you calculate 8.75% sales tax by getting it. All right, so read that cones table in, try to do this, and I'll give you a few minutes to try it, okay? I'll come around and make sure it all makes sense. And help each other. Please get together with the people sitting next to you. See what's going on. That's almost it. Are any of us having trouble reading in the cones table? That's the very first read table thing. Well, this might be an ambiguous question, by the way. Let's do you can calculate just the sales tax part, or you can calculate the price with the sales tax included. So maybe that's what we really want to know, right? And that's probably a more interesting calculation. I think that's descriptive enough. Try that. Hmm. Did we figure it out? I want the total price. What am I going to multiply it by? Let's see. Does any brave soul want to tell me what they did? Yeah.
I started with the operator, so the total equal.
Oh, nice. Okay.
Same thing as that, instead of the times 2,
Mm.
0.018.
Nice. So that'll give me that tax amount. And then if I print total, that's where it's saved right now. Good. Nice. And so if I want to take this total and add it to the original price, you guys remember what we could do? There's a couple options. Yeah. We could take that old column and just it'll add all the pieces all up together. Like that would work. And so there's my final total. Or if you wanted to do it, there's one other option. So let me, what have I just done? Let's make this something by itself. So this is like option 1. which makes sense. This is very descriptive. I like this one, right? We would call this maybe tax plus the original price. So that's like option 1. Or you could like do it all in one fell swoop, I think. You can take the column. Option 2. And just like you can add in the price to itself. You can do it all at once, like this maybe. Like that could work. Alternatively, if we like math, we could just multiply by 1.0875. Yeah, so that would keep the original stuff in there too. That would be equivalent. So yeah, either way, that will give you an answer. And then you probably want to round this. There's a way to round it. Do I want to show that to you right now? Why not? I don't know. You'll always have these pages to look at during a test. That's my plan, at least. There's a numpy dot round on an array. We could round it to the nearest 2. So like you take this bad boy and be like, I first have to import numpy as np again. But you can say np.round, whatever this array is, to 2 decimal places. And then you have like pretty prices. That would work. That's another way to do it. Okay, so yeah, I hope that makes sense. And let us attach. Here's like option 3. Let's take that. We still have the cones table. Let's add a price with tax column. Let's do that. Because like we know how to calculate the contents of the column now. Let's do that. I think it'll be great. So like, I don't know, tax, let's use as many variables as we can right now. 0.0875, that's my tax rate. And then we'll be like cones dot with column, price with tax. And then how do I calculate the price with tax? Let's do it this way. Something like this. Tax rate, tax. And then this one will be the total price after applying the tax. So that will give me this one. Okay. And I haven't rounded it. I'll show you something cool that'll like automatically round it. But still, the old cones table is still the same. That's how the with column works. It makes a new table, gives you back the new table. One thing a nice pattern that we're going to use a lot is like, no, I actually wanted that to mess with the original table. You can say cones equals, cones attach a thing, and put that back into cones. Does that make sense? That's something you can do. And so if I were to do it this way and say cones now it really does have that new column. I've updated it. Does that make sense? I've taken the old one, like start with the old one, create this, put it back into cones. I've attached it. And so now if I ask for cones just by itself, it really is that thing, which is nice. All right, so I've got that thing. And now we got this calculation done. You probably want it rounded to the nearest cent. You could play this game with the NumPy library, but there's actually an easier way if you want it to be displayed. There are different formatters for tables. And I don't remember if these are on either of these pages. So it's like set format. No, not on that one. It's in the book. Set format. No, not on this one either. So I guess it's not as important as it should be. But one day, if you want to make something look pretty, say table.setFormat. You give the name of the column, and then you give one of these words. These are like built-in formatters. We're dealing with currency, and so it's like going to automatically round it and add a $sign. So it's kind of cool. Let me just show that to you. Whee! So we can say cones dot set format for the price with tax column. And use the currency formatter. It's built in. If I type tab, it like auto completes it because it knows it exists. It's part of the library. And then look at what it does. It puts a little $sign and it rounds it. That's so cute. There's a way to say currency formatter with a different, like, if you don't live in America, with a different symbol here. But this is good enough for now. And this is one of the few ones that I want to teach you that actually updates the cones table. So if I ask for cones again, it has messed with the way this column is displayed. Okay, so that's actually updating the table itself. So that's kind of cool. Yeah, that's a formatter. There are different kinds of formatters. The currency formatter, there is number formatter, percent formatter. So let me just show you those real quick, just in case you care. So like, let me make, just on the fly, a blank little table with a column called X. And inside of X, I'll put an array with a bunch of giant numbers. Make array with like 1,000, 10,000 and like a bunch of nines. So there's my table. It's very hard to read these numbers, especially this one. Like, what is that number? And so what the number formatter does, I'm trying to go here this whole time. The number formatter like adds the commas in the right spot and makes it pretty. So you can say, take this table, it's disgusting, set format of the X column with the number formatter. And so now it's like, oh yeah, thousands, millions, billions, 9 trillion something. Cool. And so that's what number formatter does. If I do the same thing with, there's also percent formatter. And so percents are numbers between 0 and 1, technically, at least in math land. And so if I have some numbers between 0 and 1, like 0.5, 0.75, 0.999, if I take that column and I use the percent formatter, it'll make it pretty and put it between 1 and 0 and 100. Like it'll turn those numbers into percentages and make them pretty. Okay, so yeah, those are ways to format different columns of your table if that is interesting to you one day. All right, does that make enough sense? These are just a bunch of ideas. Yeah.
Can you format multiple columns or does it seem like?
You sure can. You should be able to say, ooh, I don't know if I want to update. Let me make a temporary table being the same as cones. And then, all right, temp. Let's do set format. Oh shoot. Let's undo the format for the tax one and add the format for the price one. Let's do that. I think you should be allowed to do that. I think it's 2 dots though. It's like temp dot set format of the price column with the currency formatter dot again. I think set format of the price with tax column price with tax to be like number formatter or something that is different. And so now it kind of flip-flopped. Does that make sense? So yeah, it's just you can chain the dots as much as you want with new operations, which is very cool. And due to the way that Python works, I don't know if this actually, yeah, it did actually update the old cones table too. That's fun. That's okay. Let's go back to that one. Complicated. I guess I can undo what I just did by restarting the kernel and telling it to do. Why can't I delete this one? Okay, so let me get back to a blank slate before I mess with the cones table. I'll say restart kernel and run all cells, like rerun everything. All right, let's do some stuff that we already remember now. So we've got the cones table. You can ask for pieces of it and be like, hey, cones table, I only care about the flavor and the total price with tax. I don't care about the color, the original price. What I'm going there for as a consumer is I want to know the options of flavors and I want to know the final price. And so that is going to be .select. We're doing it in order, nice. So table.select, and you can give as many columns as you want as arguments. Like, take only these and give me just those back, please. So if I've got cones and I ask for select, just give me the flavor, please, and give me that price with tax. Again, you can use double quotes or single quotes. Does not matter. Boop. And so that, again, it creates a new table. It's not update the old one, but like maybe this is the important information now, especially for that like Pokemon table. I only want the name of the Pokemon and their type and whatever. That's much easier. This also works with indices. So the flavor index of the label was 0, right? 0, and the price with tax was 0, 1, 2, 3. Okay, let's do those. So slightly less typing, but slightly less descriptive. Give me labels 0 and 3, please. Select just those columns. Okay, so indices work too. It's happy. And yeah, remember that there is a difference though. If you can select a single column, that's fine. Cones.select, just the flavor column, but you get that back as a table with a label and a single column, and it looks pretty. That is different to selecting just the column. Column, there's a difference, right? Cones.column flavor. This one gives you back the contents as an array that you can do math on. There's a difference. Okay, if it was numbers, you have to use this one. So only this one makes an array. This one gives you back just a table with a single column, essentially. So there's a slight difference there that I hope you kind of see. Okay. So the opposite of select is drop. You can say I've got a table. I like most of the columns, but I want to get rid of some. So like cones dot drop price. I don't care about the original price anymore. Something like that. So it makes the table and gets rid of that old one that you didn't care about. It just gives you the ones that, the existing ones except for this one and potentially more. You can drop a few columns if you want to. That's totally fine. Okay. And again, dot drop makes a new table. Capital table. So that you have not lost the old one. Okay. There's that. So that's a drop. And we've done sort already, right? So let's do that again. So we've got cones. Let's say I'd really like to know the cheapest ice cream cones. So cones.sort by the column price with tax. So now it's in order from smallest to biggest, and all ties are broken arbitrarily. But now I know that, all right, this one's the cheapest. Cool. And so by default, it's ascending from small to big. There isn't a secret special option you can give as a second argument. You can say descending equals true if you're rich and you really just want the most expensive thing there. You can look at those first. Okay, so that's descending equals true. The spacing around this doesn't matter. It's like a variable declaration within the function call. But it's a special argument to the function with a name. It's a named argument. So that's here somewhere. Dot sort. So yeah, you can say its name or the index of the column you want to sort by, and then this one's optional. So by default, descending is false. You can say, no, descending true, please. So yeah, that's how that works. Any questions about sort? Remember it, yeah? So it's just all stuff that you can do to look at your tables and get stuff out. I think that is most of what I wanted to say there. How are we doing? Yeah, I think that is, we're almost home free. Let's see. And again, the original cones table did not change. It's always updating and creating a brand new thing. Okay? So nice and non-destructive is the technical term. Okay? So I just have a few more things, and then you kind of know tables. So, and then you can ask a lot of questions about tables that you get. So I'm excited. So let's see here. One of the few things I still need to show you is .take. So where's that? Table.take. It's way down here. Table.take. And then you can give either just one thing or a sequence of things. And I'll show you what I mean by that. But table.take, you can pick out rows you care about by indices. All right, with integer indices. So let's say this is your cookies table. You can take just the first thing by saying cookies.take 0. It gives you just that one row. It gives you back a whole table with just that one row in it, though. You can take the last thing by doing num rows minus 1. Or you can take a bunch of things by saying 0, 1, and 2. That's giving you the 0th row, the first row, 1th row, the 2th row. I don't know if that counts as 1 and 2. So first, second, and third row, you can do it like this. Or you can make a range, and I'll show that to you. Okay? So .take lets you get things. So here's my cones table. I can ask for, like, I really like this strawberry one. Which index is this strawberry row? It's 0, 1, 2, 3, 4. So I can say cones.take 4. Give me just that one thing. Still gives you back a whole table with just one row now. Okay? Cones.take 4. You can take a few things. Cones.take, I don't know, 1, 3, 5. So how many are there? It goes up to 0, 1, 2, 3, 4, 5, 6. So 7 doesn't actually exist. It will complain if you try to use an index that does not exist. So go up to just 5. So I just want the odd indices as things. There's a quicker way to get this, actually. A more interesting way to get it. Do you guys remember, if I do import numpy as np again, you remember your sequency stuff to make sequences? This is what we talked about at kind of the end. You remember np.arange? It creates an array with a certain range. Like if I want to range from 1 to 100, I'll give arange 101. So starting at this, going up to this, potentially with an offset. It's like add, I don't know, 5 at a time. That looks weird. Let's start at 0. Add 5 at a time. That's kind of cool. So you can make ranges and give those to take. So another way to get just the odd stuff, out of this table, the odd indices only, you say cones.take. I would like to take this range, starting at index 1, incrementing by 2. I just want the odd ones, right? 1, 3, 5, 7. I want to go all the way up until the end of the table, but not including the end of the table. The last index of every table is the number of rows. Like there's 7 rows, right? The last index of the table is 0, 1, 2, 3, 4, 5, 6. It's always the number of the rows minus 1. So we never want to go up to that one. So that's our ending index. It's like from 1 up to cones dot gnome rows. Does that make sense? It'll never hit that. Like no matter how big the table is, that'll always work. Take that, and that's another way to get this. It's a more interesting way, I think. For longer tables, that's kind of cool. Right? So that's all the odd indices, no matter the size of the table. It'll always work because it'll go look and see like what does the ending value need to be here. I think that's cool. Okay. All right. Are you ready for the last piece of table knowledge I want to give you? This is the most complicated piece. It's dot where. All right, and this is what gives us true power. All right, it's amazing. Cones, table dot where, whatever your table is, you can ask for pieces of your table that, what's the right way to describe this for the first time, that answer yes to a question that you ask. All right, so you say table dot where, give a name of a column and give what's called a predicate, which is a yes or no question that you could ask about that column. And what will happen is Python will go in and give you back just the rows where that answer is yes or true, remember. So that's pretty sweet. And so there's a bunch of different ways to ask questions. Let me show you the easiest way. You can say cones.where and get the name of a column. So first of all, what does cones look like again? There's cones. Cones.where the flavor is chocolate. All right. If you want something that's equal to, there's shorthand, just like give the thing you want it to be. So chocolate. And this will pick out the pieces of the table, the rows that only have where the flavor is set to exactly chocolate. Does that make sense? Where this is true, where the flavor is chocolate. So by default, it's looking for equality. By default, this is an equality check. Okay, so that's what's going on there. And let's see. Dun, dun, dun. Yeah, that's that answer. But there's other checks, all right? And the checks look like this. It's a little disgusting. You have to say the word R, which sometimes doesn't work very well. Does it say anything here about R dot? It gives you no, I guess it does. All of your R dot stuff are down here. Table dot where predicates. R equal to, R above. It might be here in a prettier way. It is. You can do all of these, and I made a table on our slides as well. But this is what you can ask about. And it always starts with R, and I don't really like the way that they did that. But let me show you the equivalent in the long form, because like by default it does equal to. Let me just show you what I mean by that. Okay. This is a little complicated, but I promise that you'll get it. So instead of this is the shorthand, but the longhand way of doing this is saying cones.where the flavor values are equal to chocolate. That's how I want you to read it. Because otherwise, like, you use the word is, and it's supposed to be plural. I don't know why, because they said are. Okay, so that's what that is shorthand for. The above is shorthand for this. Okay, so it'll pick out just the tables. All right. Start with the cones table, pick out just the columns where the flavor values are equal to chocolate. You see how I'm reading that? That's how I want you to read it. It's a little weird. But that gives us the true power because you can replace equal to with all of these other things. So where the values are above, strictly above, greater than, above or equal to, below. They really like to be wordy in this library, which I don't fully agree with. Below or equal to, between, strictly between or equal to, containing, which has to do with strings, stirs. Like it contains this text. And all the opposites are also there. You just start with not underscores, like not equal to, not above, not blah, blah, blah. All of those exist. That's what you get. So if I just have a $5 bill in my pocket, I could ask the question like, all right, what cones can I buy right now? Cones where the values of the price with tax column are below, I guess below or equal to 5. Isn't that cool? That's where you get true power. I think that this is the most powerful thing in the table library. Okay? So are below or equal to 5. And so it just picked out those, and like those are my options right now. All right? Are there any questions about that? Does that make enough sense? You can ask those kinds of questions and get back just the rows where those work out. Okay? And then you can do extra things. So this gives you a table back. It's like, all right, I've got this answer, and then maybe I want to see the values sorted in increasing price. So I can look at the cheapest thing less than $5 up to the most expensive thing less than $5. So price, sort by price with tax. You can keep on chaining these ideas one after the other. So that's kind of cool. All right, you can do that. And then all these other things are like numbers, but containing has to do with strings. It's like it contains this string somewhere. So cones.where, here's what cones looks like again. Cones.where, like the color, I don't know, I really want chocolate, but I don't care what kind of chocolate. So like where the color column values are containing brown. Some kind of chocolate, please. It's like it picks them out because like brown is contained in these rows for the color column. Isn't that neat? I like it. So yeah, dot where, very powerful. Are there questions about that? I think you could do it. All right. So we have a little bit of time left today, not a ton. And so what I'd like to do is I want us to play around together, honestly. This is everything you can do to tables. I think you can see the power, and like you could ask real questions now for data sets. So like let's start with one that we've used before, and then we'll do more next time. All right. So and then I'll assign due dates. So let's do the Pokemon data set again. I would like to give that to you. All right. I'd like you to import it yourself. I want you to remember how. All right. Just like you did for the cones just now. Please go to the code from class. You go to data 8. You find it is Pokemon.csv. All right. Please download that. Read it into a table. All right. I'll do it with you in just a second after you try. And my question for you is, as a group, please get together with some of the people sitting next to you. And I think the best way for you to give me what I want right now is, I guess you could shout it out if you'd like. You can write down things, but just in case we're shy, I've made this cute little written nice page that I can't remember if we've used in this class yet. So you can write cute little posts. And so maybe as a group, you can go to this written nice page and like type down what I'm asking you to do right now. So here is your task for the next few minutes. I'd like you to like say hello to the people sitting next to you, get together, exchange ideas about how to do this, but read the Pokemon data into a table, call it Pokemon Call, whatever you want. And then I'd like you to like stare at that table for a second. Look at the rows, look at the columns. You can look at the CSV file, open it up in Excel if you need to. But like come up with 2 questions that you think you could answer with your current knowledge. Like, all right, I've got this table. I know that I can do these things to this table. Like, what are some interesting questions that you could ask about the Pokemon data? And then I will take some of your ideas and we will work on them together. How's that sound? I think that'll be fun. It's like, take a few minutes to try to do this. As a group, come up with some good ideas, and please write them in the written nice page if you can. And let me know if you have any questions, by the way. It's like, remember how to read it. Table dot read underscore table, right? Forget the Pokemon one. Any questions? An example question could be like, give me the Gen 1 Pokemon with the highest attack or something. I don't know. Something like that. those are things you could ask now. And I will show you how. And that's tomorrow. And you can come up with more than two questions if you have a lot of questions. That's fine. But I'd rather do stuff you want to do. Like your ideas. I think that'll be more fun. Interesting. And then if you come up with your questions early, just like try to solve them. I'll do them eventually. Like see if you remember how. Like look at the documentation page. It's like, how could I ask this question and get the answer back? Question?
You want us to apply like just in regular English or just like what the code?
Oh no, English. Definitely English, because we haven't. It might be a complicated question that would take a lot of code.
What's the function just to be a couple of something?
Oh, that's show. That's show, and you get how many you want. 3, 10. By default, it's 10. If you want every single row, you say show with nothing. A minute to think about things. Maybe try them yourself, and then I'll pick a few. We'll do them up here together. I think that will be educational, like how to break down the problem. Because maybe you have a question you're not sure how to solve, and that's the whole point. Like we're going to learn today. All right, let's see. Let us see what we're thinking or ideas. It's okay if you don't know Pokemon very well, but hopefully you found like a column that's like, oh, that seems interesting to know more about these values in this particular way. But yeah, let's take a look and try things together. What was I gonna? Oh, first, the question that I got while you were working is, I guess one that I showed you before, but I want to make sure you know it now. So like, there's a dot show. This will actually be useful if you sort things and you want like the top 10 or something. So like Cohen's dot show, give me 3 things. Give me the top 3 things. So that works. And then dot show with nothing shows you everything. Dot show with nothing shows everything, which may be a lot if you have a very long table. Do that one cautiously, okay? All right, let's see what we're thinking. I'm excited. Cool. Remember to press submit, otherwise I can't see it. So yeah, let's see. how many Pokemon have a value of 2 against fire? So like, I guess that means it's super effective against fire. How many Pokemon have more than 2 abilities? Nice. I don't think we have the knowledge. I'll show you maybe, but we may not have the knowledge to answer the second one in a way that I can teach you right now. But yeah, as you're thinking of ideas, just keep on pressing submit. So let's try these. Like, all right, how many Pokemon have a value of 2 against fire? Can anybody think about, like, well, first of all, let's read the thing. So I'll call it Pokemon equals table.read table. It's in my data folder / Pokemon.csv. All right. So there it is. Here's what it looks like. It's a little disgusting. There's a lot going on. It's like a bunch of names. Like, name is way over here. Why? Of course, why not? So there's that. And so our question was, how many Pokemon have a value of 2 against fire? All right. So can anybody tell me how they might go about, like, figuring that out? So here's the against fire column. We want just the ones where it's 2. So what kind of operation should I be using here? What were we just doing? I think it's going to be a dot where, right? It's like where this value is 2. Yeah, something like that. So that's how you would ask that question. It's like, okay, Pokemon. And let me clean this up first of all. Like, all right, here's my temp table. Pokemon dot. Please just give me select the name and give me the against fire. Like, give me just the things I care about right now, because everything else is disgusting. It's way too much going on. Like, if this is all I need right now, I need the name, because eventually I want to see the name, and then against fire, right? This will make it easier for me to see the answer, right? So, okay, there's my temporary table. I'll say temp.where against fire, like where the against fire values are equal to 2. Or because by default it's that, you can just say where it's 2, just like that. So either one would work, but I'll use the long form one so we get practice with it. If you like to think in the singular, and I sure do as well, here is something disgusting that you could do. First of all, let's find the answer. Here are your Pokemon, and you can show them all if you want. Isn't that fun? So there's apparently 187, because by default it shows you 10 rows. If you want to see all of them, you say dot show with nothing. It's like, here is every single Pokemon that is really good against fire. It's probably all the water type Pokemon. Let's get their type 1 as well, just to make sure that because that's another question we could ask. Like, what were they all water Pokemon? I don't know. And it looks like a lot of them were. Some grass Pokemon are good against fire. Bug Pokemon. I guess there's more of those. Never mind. Interesting. See, I don't remember. But that's good to know. Cool. So, yeah, that's like that. Those are questions that we could ask, and I hope that makes sense. Let's see. What was I going to say? There was something, and I forgot it. It may come back to me again. But, yeah. Does that make sense? How I just went about, okay, that's my question. How do I break down this table? Let me get out the pieces I care about, and then, like, select the stuff I want. Because that's how you do it. That's what makes sense. And if you'd like to play along, like, try it yourself first. I'll just go in order. How many Pokemon have more than 2 abilities? That might be hard to answer with our current knowledge. Because with the Pokemon table, these are abilities. Do some of them have more than 2? I don't know what abilities is saying here. Dot take. Let's get not just the first 10. Let's get the second 10. A range from index 10 on to 20. These are the next 10. Yeah, some of these do have 3 or more. I don't know what that means, but all right, let's get the abilities that are larger. It's unfortunate. What is going on? This might be a little weird. Abilities. Because essentially what this is a sequence as a column, as like an entry in a column. And so there's a way to read in the sequence and take the length of those sequences. That is not something I have taught you how to do yet, though. But I promise that there's a way. You could, let's see. No, I think that would be too complicated. But what could we do? Could we sort? You could ask for the column that is the abilities column. And then for each of these columns, I guess you could read it in and convert it to into a sequence. There's a way to do that. And then you can call len on every value because every one of those is going to be a sequence. So I have not taught you that yet, but that's a great question. Remember that question once I teach you how to do something called a loop. Okay, we'll get there. But that's a great question. I don't think we can answer it right now though. All right. What is the Gen 2 Pokemon with the highest speed? What is the happiest Pokemon? Cool. So we can ask those questions. Let's figure it out. So the Pokemon table looks like this. And again, it's disgusting. So let's just like select out. We care about the name probably. It's lowercase name. And we care about speed and happiness. Are those the words that we need here? Speed.
It's base.
Base happiness. Thank you. Base happiness. Probably an easier way to look at the labels is to ask for Pokemon .labels, right? So please try all this yourself, and then you can see them all. Like that would work. Base happiness. Okay, and so that's my table. Let's make that my temp table now. That's what I'm going to work with to do stuff. And my question is, Gen 2 Pokemon with the highest... Oh, I need the generation too. Select generation. Is it just generation? Probably. Yeah, cool. So I would like the Gen 2 Pokemon only with the highest speed. So a great way to ask that is like, all right, I got my temp table. I'd like to pick out where the generation is 2, where generation is 2, right? You can do this in any order, by the way, but like that's how I think about it. So now I've got just the Gen 2 Pokemon. Does that make sense? And then I want to add on to that. Take the Gen 2 Pokemon, and now I want to sort by their speed, yes? Now I've got the ones I care about. Let's sort by their speed. Dot sort by speed, but it's got to be descending, right? Speed descending equals true. Isn't that cool? Like we can do that. And here they all are. If you want the top 10, it's by default printing that out to you. If you want the top 15, like show 15 of them. Does that setup make sense? You could have gone in any order. You could have sorted by speed first and then taken the Generation 2 Pokemon out. The order of those did not matter. Does that make sense? Like what question do you want to ask first to whittle it down, kind of. The world is your oyster. But apparently, Crobat, very, very fast Pokemon in Generation 2. Also decently happy. All right, what about the happiest Pokemon in any generation? That's just like temp was every Pokemon with all these values only. So I can take temp dot sort by the base happiness descending again. Descending equals true. Right? So no matter what question you have, most of them we can answer right now. So look at all these guys. Very, very happy Pokemon. Give me 20 of them. Okay, yeah, so like 140 I guess is the happiest amount it could possibly be. So good for those guys. Thinking good thoughts. Yeah, does it make sense how I asked that question as well? Yeah. How many Pokemon have an ability less than 1 against poison? Nice. Let's figure this out. Dun, dun, dun. So again, my Pokemon table looks like this. Let's select out just the pieces I care about. So let's make my temp table be Pokemon. Select. Usually we care about their name. We want a name involved in our answer. And then it's going to be ability less than 1 against poison. So it's probably against poison. So which Pokemon are not good against poison, I guess? Against poison, less than 1. So let's see. I guess I want just against poison, right? Those are the 2 pieces I care about. That should appear in my answer. And all right, that's my temp table. I'll take temp dot. We could sort, but we could also do a dot where. Temp where. Give me the values where the against poison column are. And I guess, do we want strictly less than 1 or less than or equal to 1? What should we have? You can do either. Let's do less than or equal to. Let's do both, honestly. The less than or equal to is below or equal to, I think. Yeah, below or equal to, and then just strictly less than is below. So where the values are below or equal to 1. Here they are, in this order. There's quite a few. Show 20 of them. I don't know. Cool, so there's a few. If you want it strictly smaller, you just say below. Boop. Oh, some are horrible. Wow. 0.25, I didn't even know that was an option.
I think when they say against, what mean how much they resist.
Oh, that's good then. Okay, so those are good against poison.
If it's bigger than 1, then it means they're weak to it.
Thank you. Okay, yeah, I don't know. It's been too long. Cool. Well, now we know. It was a good question. Let's look for. Nice. We're on to this one right now. Male and female Pokemon speeds. Oh, I like that. Is there? Where do we have the gender? I know there's like a percentage, which is very.
Percent over below 50.
Percent over?
Percent male.
Percent male over 50. I see. Below 50. That would make sense to me. You can see that this game was targeted towards young boys by having the popular Pokemon usually be male.
I think when they say that means that if it's bigger than 50, they're more like the Pokemon's more likely to be male when you find it.
Yeah, more likely. Exactly. So let's see here. So yeah, there's some of them are strictly 50-50, maybe some are less than 50. Yeah, but that's a great question to ask. All right. Below or above, let's see. Male and female Pokemon speeds. So I would like percentage male. We can calculate percentage. Ooh, I can show that to you. That'll be fun. Here, okay, temp equals, let's select out. I want the name. Select. I have an idea. Select the name, select the percentage male, and then we want speed. Dun, dun, dun. If we, I don't know, if we don't like this column, we like equality, we can make a percentage female column. Can't we? How would we do that? Well, here's my temp table. How could I make a percentage female column? Well, I can get the column for percent male. And then I could subtract. Like, there it is. And I could take 100 minus that. Cool. Does that make sense? I like that. Oh, there's percentage female. So like I can add that column. It's like temp equals temp dot with a column called percentage female. Assuming that's all you get in Pokemon Land. I'm not sure. But maybe we want to work with that. I don't know. You could add that column based on a previous column. That's a great question now that I think about it. Because you could add more things as you need. So now we're talking about speed. All right, so if the Pokemon are more likely to, for the Pokemon that are more likely to be female, what is their speed? Let me show that to you. So temp dot where the percentage female is, where the percentage female values are strictly above 50. So those are all the Pokemon that are more likely to be female. Let's look at their speed. All right. Let's look at their speed values. Dot column speed. So there are all the speed values of Pokemon that are more likely to be female. And there's a way to take the average of them. Because this is now an array. I think I showed you this very briefly last time. It's dot mean to get the average. Did what I just did make sense? Here's the Pokemon that are more likely to be female, with the percentage female strictly above 50. Get their speed column out as an array, because dot column gives you an array, and take the average of that array. So this is the average speed of Pokemon that are more likely to be female. Cool. And let's do the opposite for where it's more likely to be male. percentage male. Get their speed. Give me the mean. That's sexist. But now we know. All right. That's a great question to ask. That's very good. So do you see what we did there? Like we could add a column. We could do some math. We can get a column out and ask, like, we can do NumPy stuff. Hey, give me that array's average. Give me that array's, do the median if you need to. Like, that's the thing. That's pretty cool. You can get how many there were, like how many, because we also know that there's definitely going to be a disproportionate amount because of the target audience of this game originally. Like, how many Pokemon are, wait a second. That doesn't seem right. Yeah, there's more of those. Give me, dun dun dun. Give me the column speed. And give me, like, the length of that. So you can ask how many there were. Or I guess, like, this is going to give you back a table, isn't it? You can ask for num rows. Oh, wait. What have I not done? Oh, no. Before you get out the speed. It's like, apparently there's 53 Pokemon that are more likely to be female. And there are... Do the same for male. Because this gives you back the whole of all of them, right? Then you can ask for, all right, how many rows were there? Because that's how many. And again, disproportionate, sadly, in Pokemon Land. So, yeah. These are great questions to be asking. I'm very happy. So we're showing stuff. Let's see. I think we have a decent amount of time to get through at least some of these last ones. Let me read these real quick and see like which one would be the most educational. Legendary Pokemon. And you guys can try any of these yourself, of course, as I'm thinking. One of the names of the electric type Pokemon from Generation 1. I like that one. We can try that one. Pokédex number, primary type, speed stat. Oh, this is just like an informational question, I think. The Pokédex is the, like, there's an order for Pokemon, like, there's a number assigned to them, an ID number, essentially. That was arbitrary. The primary type is, like, they have mostly that kind of power, and speed is, like, how fast they are, like, can they avoid an attack during a battle kind of thing, I think, if I remember correctly. It's been a while. How many Pokemon have the ability to run? Ooh, I like that one too, because that'll give us the, okay, yeah, I like two of those. So let's do this question. What are the names of the electric type Pokemon from Generation 1? So, all right, Pokemon, we've got, which pieces of this do we need? We always want the name. We always want the, dun dun dun, where am I? We want the type, I guess the primary type, type 1, and the generation. Those are the pieces that we need there. So I'll select out the name, the primary type, so type 1, and then the generation. Beep. So there's those. And honestly, I don't need to make a temp table. I can work with this table if I want to. It's like, all right, take that, where? What am I asking? I would like electric type Pokemon. I want generation to be 1. So those are equality checks, right? It's not like less than, greater than. It's like, it's electric. It's from Gen 1. So where the, I don't know, do it in any order. So where the type 1 is electric. And honestly, again, let's have some practice with some other stuff. Let's make a temp table for a second. Temp equals all that. And before I do, like, this is what I get, but I don't like that it's called type 1 because that's like the primary type. So let's relabel. Relabeled type 1 to be just type. Better, yeah? So you can do that. You can do that. So temp equals that. There's my temporary table. And now I want to select out, or where out. Give me all of the Pokemon that are electric from Generation 1. So where the type is electric. So remember that the shorthand, you don't have to do the R equal to if you don't want to, if it's just a quality check. So this will give me all the electric Pokemon, and then I want to whittle that down further by selecting or wearing against the generation. So where the generation is equal to 1. So I could say 1 here, or if you want to spell it out, it's like where the generation values are equal to 1. Okay? And there they are. Not a lot of them. Cute. Pikachu, of course, is the first. Fun. Does that question make sense? And the answer, and how we went about finding it. I think that's cool. Oh, I remember what I was going to say a long time ago. So let me show you something very disgusting that you could think about doing one day, because Python doesn't care. When I was first reading the textbook, I was like, I don't like that it's called R. It's like where generation is equal to 1, right? That's what I'm thinking in my head. I had to add in the word values to have it make sense. Where the generation values are equal to 1. But if you read it as is in your head, you can make it is. There is a keyword in Python. You cannot reuse it. There is something called is already. You cannot reuse it and make it into a name. But capital is fair game. So you could say is equals R if you would like to in Python. And then you can say where generation is equal to 1. I don't suggest ever doing this, but this is a possibility in Python land. Please never do this, but this is cool. It's a possibility, all right? So there's that one, if you ever want to. It's a little weird, though, all right? And then let's do the one more that I wanted to see here. How many Pokemon have the ability run away? I like that one. So, okay, we got Pokemon. Let's select the name. And I think it's abilities. Find out, yeah. So we got those. So here's every Pokemon's name and all their abilities in that order. And we can get where the abilities, there's multiple abilities. So it's going to be where the abilities values are containing runaway. See that? Containing runaway. It's got to be capitalized in that way, I think. And there they all are. And we can show them all with dot show with nothing. It'll give me everything. And then you get to see all of them and all of their other stuff too. Cool. These are very, I don't know, very scared Pokemon. They like to run. I think that is some good examples of stuff that you could want to do. Are there any questions about how I found this one and thought about it? No matter what question you have, most of them we can answer now. And this is like basic data science. Like you can do it now. That's really cool, I think. And so we're going to do more examples of this next time. We're going to keep playing this game next time. I have more, or even cooler data sets. But if you would like to go to our Coach Room class to study and try it out yourself, I have a bunch of data files that we'll eventually use. Some of them we'll be using next time. But this is enough to get us started on our next assignment. So like you know that they're already out, but let me, for the last things that we do today, let me assign schedule due dates for the following assignments, and they're supposed to be done apparently in this order: Lab 2, then Homework 2, then Lab 3. They needed knowledge up to Chapter 6, and now we have it. We're not actually done with these slides. We're just going to practice Chapter 6 some more and get better at it, but now you can at least do these, okay? And so you'll be really ready to have more examples next time. So let's think about due dates now. Let's look at our calendar. All right, let me write some notes for myself here. We've got Lab 1, then Lab 1 is due in 30 minutes. Homework 1 is going to be due on Friday. And so let's just keep on sticking to Wednesday and Fridays as due dates. Does that sound good? That's fine with me. And so like in this order, Lab 2 I'll make due on the 27th. Let me write this down. And then I'll do it after I've let you start working. So Lab 2, 27th. And then 29th will be Homework 2. And then Lab 3 will be the next week, Wednesday. So that'll be the 3rd of September. So that's Lab 3, the 3rd. All right, so I think that'll be when I make the dates. I'll do that on my own time, though, while you're working. And I think that's everything that I wanted to say. Are there any questions about tables before I let you do your work? And ask lots of questions. All right, that is all that I have for the day.